Good morning, chemistry fans. Here we are. It's lab time. I have my trusty assistant back with us, and this is really what we finished the year with is, as I told you in our previous learning, a very common everyday lab, very simple, and titration lab. You saw in our previous learning that the formula is really the same as making a dilution, except now we say MAVA, MBVB. And what we're going to do, what we would be doing if you were here, this would be the same as our 2-week qualitative lab where you had spent 2 weeks really doing the work on your own. This would have been the same thing. You would have spent a couple weeks on your own doing titrations and stuff. Now I get to do them for you. We have a few things here. We have what's called an Erlenmeyer flask, which are awesome. It's been rinsed out for doing titrations. This here that I have turned, and I'm going to turn it back again, is what's called a titration burette. And that is what you do titrations with. It is just a perfectly sized and marked tube that holds base. And you can slowly run base into acid. That's the way you have to go, because acid in the base splatters, and that's not good. Always having lots of distilled water nearby for a titration. What we're first going to titrate here is vinegar, which is a weak acid, acetic acid, and I'm putting 10 milliliters in the Erlenmeyer flask. And then I'm also putting in just a couple of drops of phenolphthalein indicator. Whoop, a few more than needed. It's not a measure of how much, it's a measure of once you get a couple drops in. Phenolphthalein indicator is an indicator that turns pink in the presence of hydroxide ions. So as the acid and the base meet each other, neutralize and cancel out hydrogens, hydroxides, what we want to do is put enough base in there so that last drop turns it the lightest color pink. I'll say pink because that's the phenolphthalein color. You'll see through some of the household stuff we do here that if the household stuff has a color to it, then it might not be. So you're looking for that one drop that does the color change. And in this case, it's going to be pink because the vinegar is clear. You can see right now that it's staying clear anyhow because it's all acid. So the indicator isn't going to do anything. And then all I do is place it under the titration burette, and then I'm going to slowly start running the base in there until I hit that point. Now, the titration burette, because it's marked in milliliters from 0 to 50, I mark where I start and then I mark where I end, and I know exactly how much stuff I used. In this case, I'm starting at 1 milliliter at the top, and I've had 10 milliliters of vinegar. And so I slowly open the valve, and if you could see through, I'll show you in a second. I'll try and hold it up so you can see. But if you can look through kind of the holder and stuff, what you can see is, let me switch it over here. Let me switch it a little so maybe you can see it. What you can see is as the base hits the liquid, you'll see a little bit of pink color right where it hits. It's hard to see in your thing. Right where it hits, but it's hard for you to see on camera. But it goes away because it's the base is being neutralized from the acid. It's when that pink color stays that I want to stop. And so I'm letting it slowly drip in, and I'm kind of mixing it up to help the hydrogens and the hydroxides find each other. Okay. Titration labs take patience, and especially with stuff that doesn't readily or has more of a delayed action in turning pink. Sometimes it turns pink and then disappears. You're going to see that. So it just takes patience to kind of watch, let it drip in slowly. You can see, or I can see, and if you were here, you could see that every time that the base hits there, it turns pink, but then it disappears as it gets neutralized by the acid. And again, it's that one drop that it turns pink and stays pink means we hit the OH, it's close enough that we hit the hydroxide with just a couple of hydroxide molecules. I'll let it go for a minute and see if you can see the pink. Let me shut this off here. Yeah, see, the minute I pick it up, it starts mixing up and it's hard for you to see. Okay. I'll move it up so I can pick it up faster. I'm being careful and deliberate in what I'm doing here so you get good results. I'll know when it's ready to turn for the most part because it will be hard as I mix it up for the pink to disappear. That's when I can just go one drop at a time and find that one last drop. Here, let me see if I can. You always do titrations with white paper. So you can see, you can kind of see there a little bit of that pink in there, and then it goes away. And that's why we have white paper, blank white paper under there, so you can see the faintest of the color changes when you need to. Trying to go carefully, just a little drop by drop. It's getting very close. I've got to be careful here now. So I'm kind of turning it off and on, letting a couple drips go. Maybe a drip at a time. Mix it up. And there we go. You can barely see that difference in there, but it is just slightly pink. And I always have that one question, well, what if I'm not sure? You can always not sure, one more drop. Because one more drop is going to make that big a difference. Okay, and then as I read the tube here, we are at 33 milliliters N. So we started 1, we ended at 33. I'm going to pause while I get the next titration set up. Okay, we're back again, ready to do another titration. Now this time, and I'll show you what it looks like. It's just this bluish green stuff in the bag. It's analysis of vanish, which is the powdery stuff you don't see anymore. You used to get it in a canister. It's toilet bowl cleaner. Now it's all the gel, squeezy junk, whatever. Anyhow, you used to be able to get that, but it's an acid, as a lot of toilet bowl cleaners are. And so we're going to titrate that. First, though, a couple things. I want to again go back through. We did the vinegar. That was an acid. We started with 10 milliliters of vinegar. We started at 1 milliliter of base at the top. We went down to 33 milliliters of 0.25 molar. Our base sodium hydroxide here is always 0.25 molar. So we started at 1, stopped at 33, so we used 32 milliliters of base in the vinegar. So 10 milliliters of vinegar, 32 milliliters of 0.25 molar sodium hydroxide. What I have in here is 0.56 grams of, and you can see it's a light bluish green color, and this one isn't going to quite turn pink. It might turn a little cute little fuchsia color. Oh, I'm going to put in my couple of drops of phenolphthalein, and again, doesn't do anything. I dissolved it in water and just had some water in here so I could visually see it. So 0.56 grams of the Vanish, which if you look at your lab is 62% sodium acid sulfate. And then it's got 38% of inert, not part of the reaction, filler material type stuff that doesn't really matter for us. And one of the questions we're going to look at here is we probably won't get 62% of, we probably won't get a judge that this is 62% of the acid. And the question will just be why. And it's a very simple question that people think too hard about. Now I'm going to run the base back into it. I've got my acid, I've got, you know, it dissolved in some distilled water. I've got phenolphthalein in here, and I've got my base. And here's the beauty of a titration. We entered the vinegar one at 33 milliliters. We're just going to have that as our start point, okay, of 33 milliliters. And then again, I'm just going to carefully and start with some simple drips, carefully drop some stuff in there until I see the color change. And again, I see it kind of going pink and then disappearing right away. And I just want to be careful. I recall this one doesn't take a whole lot, if I recall. That's why I'm going slow from the start. And again, you can see the indicator right when it hits, but then as I mix it up and the hydrogens find the hydroxides and turn into water and neutralize it, then it disappears. So I'm waiting for that one drop that shows me that it's not going, you know, that doesn't disappear. Okay, I'm going to have to get careful here in a minute because it is getting harder. Let me turn it off. It is getting a little harder all the time to get it to go away. So we're at the kind of drop or two at a time extravaganza. Again, patience is a virtue when you're doing titrations. But again, this is the most commonly done lab assay in the world. Daily. Oh, I overshot. No, I got lucky. I wasn't controlling the valve. Daily titrations are going on to calculate knowledge about acids, bases, concentration, strength. It's a common, everyday, simple tool in just about any, boy, manufacturing place you could think of, just as a, even as a test to make sure things are where you want them to be. Okay. Well, I got lucky on that one. I almost overdid it. We are darn close. Steady hand. Ooh, there's a big air bubble there. I'm a little nervous. when you get air bubbles in there, they can kind of mess things up. There it goes, there it goes. We're good though. And that is, oh, darn close. I think we're about a drop away. That was it. That was one last drop from blue-green. So you can see the pink color. And that is at, reading my meniscus, 36.5 milliliters. I gotta write down the data. Okay, so in this one, we use 0.56 grams of Vanish, okay? And we dissolve that in 10 milliliters of distilled water, okay? So that was a Vanish, 0.56 grams dissolved in 10 milliliters of distilled water. And then for the 0.25 molar sodium hydroxide to neutralize it, we ended at 36.5, we started at 33. So if I do my math right, we use 3.5 milliliters of base, okay? And I'm gonna pause again and get set up for the next one. All right, back again. Whoops, sit on this. Make sure you're sitting on the stool itself. Back again. We're gonna do one more acid before we do a couple of bases. This is an unknown acid. This would be another, I don't know what it is, but I can use a titration to identify it, lab. So in here, I have 0.39, oops, I almost forgot to write that down, 0.39 grams of an unknown acid. And it doesn't really matter, but I dissolved it in about 50 milliliters of distilled water. I've added in my phenolphthalein, okay? I've got my 0.25 molar sodium hydroxide. I kind of refilled it because we're going to do a couple more titration. 0.25 molar sodium hydroxide, and it is starting at 1 milliliter again. Okay? And again, just like before, all I'm going to do is add in the base until I get that one drop that turns it, again, a pink or pinkish. The last one was a little more fuchsia than expected. And you kind of saw that. On the vinegar one, it was a very faint turn. And while the camera didn't do it justice, on the Vanish, when that drop went in, it turned. I mean, it just turned. Again, we're slowly adding stuff in here. You can see the pink when it hits, but then it disappears as it hits as the solution gets stirred. There's just too many hydrogen and hydroxides finding each other and neutralizing each other for that color to really stick around. There, I like that better. Okay. So again, we'll know that we're getting close to going drop by drop, or less rapid drop by drop, when it's more difficult for us to make that pink color that's turning right as the drop hits the solution, when it gets more difficult to get rid of it. Then we'll slow down the drip to really go drop by drop. I know this is amazingly stunning video. It's right up there with the magnesium gas lab where you got to watch it bubble for a few minutes. We are getting closer. The color is much more distinct when it hits the solution. And it is taking a little more work to disappear. I've slowed it down quite a bit. So I actually have time to give it a stir in between drops. That's just about there. I think we're, boy, that's pretty faint. I'm going to add one more drop. I think we're there, but I'm just going to carefully add one little more drop. Won't make much of a difference in our percent error. There it goes. Absolutely. Absolutely. That one last drop. The other one before may have been okay. And we are at 27. Yep, 27 milliliters. So we use 26 because 27 minus 1 is 26. So 26 milliliters of 0.25 molar sodium hydroxide and 0.39 grams of the unknown stuff. And we'll use that to determine what the acid is. All right, I'm going to pause because I need to set up for doing a base. How do you do a base? Hey, chemistry fans, back again now. We're going to solve a different conundrum, and that's this. We've got some Rolaids or it's some antacid. It's might even be Equaline, whatever generic brand. Antacids, by their name, are a base. Now we can titrate a base, but it requires a few more steps because here's the deal. In a titration tube has to be a base. A known 0.25 molar sodium hydroxide type base. You cannot put an acid in here because acid in the base splatters and is dangerous. But there's some concentration stuff I want to figure out of the Rolaids. Well, it'd be good to have the right concentration, not only to alleviate your stomach issues, but also not to harm you. Okay. So this, as you look at the procedure, is where we bring in some hydrochloric acid, a standard 0.1 molar hydrochloric acid, of which I used, just as it says in the lab, 50 milliliters. And I had 1.04 grams of antacid. So what I put in here was 1.04 grams of antacid. I neutralized it with 50 milliliters of 0.1 molar hydrochloric acid. And then I added in my phenolphthalein. And it's good because it's the chalky color of the Rolaids and it's not turning pink because it's been neutralized. And the chalky color is just the inert stuff besides the calcium carbonate that's in the Rolaids. Anyhow, that's what you have to do for a base. You have to take an acid like a hydrochloric acid, very simple monoprotic acid. You have to neutralize the base you want to test, and then bring in your sodium hydroxide and turn it to color again. So you'll know your acid moles, you'll know your sodium hydroxide moles. You can subtract the two to find your Rolaids moles because the acid would have neutralized both. And so you can take out what you know, and what you're left is what you don't know. And so again, same thing. We started at I refilled it. We're starting at 1 milliliter. And again, we had 1.04 grams of Rolaids and 50 milliliters of 0.1 molar hydrochloric acid. And again, you can see it. I'm going to start putting it in. It turns pink right away. Now here's the conundrum. I'm just going to run in a bunch. Look at that. Oh, very pink. Oh, it's staying pink. Oh, it's staying pink. Oh, it's staying pink. But it's getting less pink all the time until the point when it's back to being clear again. Or not clear, but chalky white. Remember that antacids are long lasting. They're not supposed to just fix everything right away. They're supposed to stay in there until your stomach stops kicking out all the acid that it was kicking out. And so this is what really takes patience. Is, again, I'll run a bunch in. Look at how dark pink that is, but it's going to take a while for it to neutralize and release from the inert chemicals the calcium carbonate. You can see on the camera how it's getting faint. The more I stir it, the more. It's not a speedy reaction. It's just not a fast reaction. Now it's all clear again. So this is one where we just have to be patient as we pour stuff in and wait for the time that it's really not going to go away. Okay. And because this is going to take time, I'm going to pause for a minute and I'll come back when we're done, because as thrilling as this is, it's going to take some time. Okay, we're back with the Rolaids. I'll show you that. It's hard to see, but it has maintained this faint pink for some time now. Okay, and so I think we're good. So we had 1.04 grams of Rolaids. We had 50 milliliters of 0.1 molar hydrochloric acid. And we used 8.5 milliliters of the 0.25 sodium hydroxide base because it ended at 9.5, started at 1. And then we can use that to calculate how much Rolaids can neutralize, or in this case, equaline brand neutral stuff. All right, we have one more titration, and I'm going to pause while I get it set up. Okay, chemistry fans, the excitement is here. The final titration of the day. Again, it's a base. It's just like the last Rolaids. What I have in the flask is 10 milliliters of an unknown base. Now, it's not really unknown to me, but I'm pretending that I'm you. I have 10 milliliters of an unknown base of which I want to figure out the concentration. In with that, I put in 2 drops of phenolphthalein and 40 milliliters of the 0.1 molar hydrochloric acid. And the reason for doing that again was when I put in the 10 milliliters of unknown base and hit it with the phenolphthalein, it turned dark pink. It was all base. Then I put in the acid to neutralize it. Now, to figure out the concentration of the unknown base, I'm going to neutralize again with the sodium hydroxide, the 0.25 stuff here, where I'm starting at the 9.5 milliliters I left off at in the Rolaids one. When this drops and turns that one color pink, then I'll know my acid moles, I'll know my sodium hydroxide moles. I subtract because the difference will be my unknown base. Okay. So again, same thing. I'm starting at 9.5, and I'm just going to slowly drip in. I don't think this is going to honestly take that much to neutralize out. So again, I'm going to slowly drip in my sodium hydroxide base. Carefully and slowly. Again, it's turning pink on contact and then disappearing. Yep, we are there. That is faint, but it's done. And we are at 18 milliliters to N. So if I do my math, that's 8.5 milliliters. All right. Yep. Of sodium hydroxide, 0.25 molar. So we had 10 milliliters of the unknown base, 40 milliliters of the 0.1 molar hydrochloric acid, 8.5 milliliters of the 0.25 molar sodium hydroxide. That'll conclude it. We'll do the analysis tomorrow. Hey, have a great day. It was fun labbing with you. From my assistant and I, we will talk to you later.